What is going on? Mr. Martin here. This is 11.2. We are going to talk about how to solve using square roots. Okay, so today we're going to solve equations that involve square roots. And we're going to use those square root properties we learned from the previous section, and we're going to find both our positive and negative solutions. All right, let's jump into it. So some things to know. I went ahead and just did all this for you so we could save a little bit of time, but I want you guys to be able to recognize the differences between these graphs here. So it says here the following quadratic functions have been factored and converted to vertex form and graphed. I want you to identify those differences between them with respects to their x-intercepts. So go ahead, pause the video, think about it for a little bit, and then answer these questions down at the bottom, and then come on back. All right, welcome back. So hopefully you got this. This first one on the left, there is only one intercept, and if you remember from the previous sections that we covered, we talked about how you'll get only one intercept if you have what we call a sum of squares quadratic. This one is our difference of squares, and remember, a difference of squares always has two intercepts, and they're usually the same value, just opposite signs. So you can still have two intercepts with a different quadratic that is not a difference of squares, but I just thought this would be a good example for you to see, because there is no linear term here, and you're going to see why I decided to pick this one. And then this last one, if you tried to factor it, it could not be factored. However, we could convert it to vertex form, and then we could see that when we graph it, there is no intercepts. It does not cross the x-axis. Okay, and this is very important for us to understand, because there is something here in this section that you might come across that we're not really going to do until we get to Algebra 2, and I'm going to talk about that down below right here. So I do have this little piece of important information. So the first part says, when solving with square roots, you must, okay, list the positive and negative solution. It can be written as two answers, or you can use the plus minus symbol. And what that means is, if we have the number 4, what is the square root of number 4? This is the one that most everybody knows. Remember, if we are taking square roots, we're looking for a number times itself, and that is 2 times 2, right? That equals 4. So we could say the square root of 4 equals 2. But what if I did negative 2 times negative 2? That would also equal 4. Okay, so we want positive 2 and negative 2, just like this example here. Okay, so we know that we will have a positive and a negative when we are dealing with that square root. And remember, if you don't see a value there, that is a 2. All right, the second one, it says in Algebra 1, we will not be taking, let's go ahead and underline that, we will not be taking the square root of negative numbers. Sometimes you might get something like this. Okay, we do not want to worry about this right now. You guys are not old enough for that. Just take it out of your minds. What we can do, if we did do it, they do have these things called imaginary numbers. Some of you guys might know about it. You might have seen it before, but we're not really going to worry about it in our course. You will learn this in Algebra 2 and work with it heavily. But for now, if we get to a point where we need to try and square root a negative number, we're just going to go ahead and put no solution. I do want you to add here also, there's another better way to describe this, as no real zeros. So either one of these are going to be fine. Just know that you know, when you're working, you might need to put no solution, or if it's asking you specifically to say no real zeros, make sure you understand that those are both the same thing. All right, so this section is fairly simple. Let's just go ahead and hop to it. Okay, this first example, we want to talk about solving quadratics using square roots when we have no linear term. This is simply get the variable by itself, and then we're just going to start square rooting. So right now, this first one, my variable is by itself. So I just want to go ahead and square root both sides, because remember, anytime we solve equations, we want to do the inverse operations, and to square something, the opposite of that is to square root it. So to get rid of x squared, I'm going to square root it, but I need to do that to both sides. Okay, so remember, x times x equals x squared. Okay, so if we are square rooting it, we know that we're down to 1x, right? Okay, And then, remember, we said we got to do that plus or minus. So this is just a easy way to write that. Well, the square root of 9 is 3. So you could write it like this. Save yourself a little bit of time and lead. Or you could say x is equal to positive 3 and x is equal to negative 3. Or even if you wanted to, you could say x is equal to 3 and negative 3. Any one of these will be fine. This is preferred. It just looks fancier, and we like doing fancy stuff in Mr. Martin's math class. All right, this next one, we got x squared equals 43. We got the variable term already by itself. Let's just go ahead and square root both sides. So x squared, the square root of that is single x. And then can we square root 43? Well, there are no numbers that multiplied by itself equal 43. But remember in our previous section, simplifying radicals, we wanted to see if we can simplify this down. So is there a perfect square that goes into 43? Or can we even prime factor it? No, we cannot, because 43 is indeed prime. So when you get that, remember, you must have that plus or minus. And since we cannot square root 43 or even simplify it, we can just leave our answer as plus or minus radical 43. Okay, very simple. All right, next one. We got this negative in front of that variable term. Can we ever solve for a variable when we have a negative variable? No, we cannot. If you remember my solving equations section, I always said you got to get the variable by itself and it must be positive. So let's go ahead and divide that negative 1 out. Boom, this now becomes r squared. 12 divided by negative 1 is negative 12. I'm going to try and square root both sides, but I got to a point where I am trying to square root a negative. Okay, so we need to remember, can't square root a negative. I'm just writing that down because I want you to write that down. Boom. So this is going to be no solution or no real zeros. Either one that you want to write. And then box it up. Boom. Simple. All right, I'm going to do this one also for you. Let's b squared equals 0. Square root both sides. And then we get b is equal to, what is the square root of 0? Well, that's just plain old 0. 0 times 0 equals 0. However, do we need to put the plus or minus? No, because 0 is neither positive or negative. So it's just b equals 0. All right, here we got n squared equals 90. Let's go ahead and square root both sides. We get that n is equal to, can we square root 90 by itself? Nope, but I do believe we can simplify it, right? This can break down as the square root of 9 times the square root of 10. And then we can go ahead and do n is equal to plus or minus. This becomes 3. And then we just leave that radical 10 right there. So that is a wrap. Donezo. All right, pause the video. I want to give you one to do on your own just to see if you know how to do it. Come back to it. Remember, get that variable by itself. You might need to do more than one step. All right, pause it. Come on. All right, welcome back. So hopefully you got plus or minus 2. So remember, I did say you might need to do more than one step. First, we got to add that 7 to both sides. Then we got to divide by the coefficient of our variable term, get our variable term by itself. Then you got to square root both sides because it is a b squared. And don't forget, you got your plus or minus. All right, so this is really useful to use when you have no linear term. It works out really nice and easy. All right, I only have one more example for you, and that is where we are solving quadratics using square roots. And we can do this really easily if we are already in vertex form, because we have what we call a quantity squared. Remember, this whole piece is being squared, so you're going to see what happens right here. So first things first, remember, we want to look at these as terms, right? So this is a term, this is a term, and this is a term. We want the variable term completely by itself. So what do we have next to this variable term? Well, we got this plus 8, so we want to go ahead and get rid of that first. So minus 8, minus 8. Then we have the quantity of x minus 5 squared is equal to negative 10. Now we can square root this whole thing. This is just to get rid of that squared exponent. Okay, so we square root both sides, then we get x minus 5. We no longer have that squared exponent. However, we got this square root of radical 10, so we kind of just put a stop there. I don't know why I drew that. We just stop, and we're just going to say no solution. Boom, box it up. Easy peasy. All right, next one. So here we got a few steps. Remember, this is one term, this is one term, this is one term. However, this variable term has a coefficient, so we got to make sure we know how to deal with that. So let's go ahead and get that 9 out of there first. Remember, you want to do all your addition or subtraction first. That's going to give me 3 times x plus 4 squared is equal to 27 minus 9 is 18. Then I want to get rid of that coefficient. That coefficient means multiplication, so to get rid of it, we got to divide both sides. So we're going to divide both sides. Remember, don't divide the x plus 4 by 3. This is all one term. We're just dividing by 3 to get this 3 out of the way. So we got x plus 4 squared is equal to 6. Okay, we want to square root both sides. So this and this will cancel out, and we're left with the inside here. So we got x plus 4 is equal to plus or minus, and can we square root 6? Nope, that's as simple as it gets. So we got this right here. Okay, so I'm going to show you a couple different ways to do this. One way that I've learned it is we can rewrite this as 2 equations. So let me go ahead and do that here. I'm going to draw this red arrow, and I'm going to write this in 2 different colors. So we know that we got x plus 4 on one side, so let's go ahead and do that. And we know it's equal to positive and negative radical 6. So I'm going to set this one equal to a positive radical 6. Okay, and then in purple, actually purple's close to blue, so is black. Yeah, let's just do purple. So this one, I'm going to do x plus 4, but this one is equal to negative 6, or negative radical 6 rather. Okay, and now we want to get this x by itself, so we're going to subtract that 4 from both sides, and we're going to get x is equal to negative 4 plus radical 6. So that's one solution. And then our other one is x plus 4, oops, sorry, x, we're subtracting that 4, so x is equal to negative 4 minus radical 6. Okay, so this is one way you could do it. Okay, you can just write it out as these 2 answers here. So this is one way. Let me put a number 1 next to it. I'm going to show you the other way that we can do it, which is kind of a little bit easier. Alright, so first things first, we got to add this 55 to both sides. That's going to leave us with x minus 8 squared is equal to 50. Okay. We're going to square root both sides, get rid of that exponent. So we got x minus 8 square root of 50. We can simplify that. Alright, so we got plus or minus radical 25 times radical 2. Then this now becomes x minus 8 is equal to square root of 25 is 5. Don't forget your plus or minus radical 2. Okay, so this plus or minus is designated only to the 5 radical 2. Okay, but if I want this x by itself, I got to add 8 to both sides. So I could just jump and do like this. X is equal to, I'm going to add that 8 to both sides, so it's going to be a positive 8. And then I could simply drop this down as plus or minus 5 radical 2. Okay, so this is the second way you can go about it. But the reason why I wanted to show you both, okay, is because sometimes you need to do this one right here. And I'll show you where. It's probably the next one. Oh, did he set it up that way? He sure did. All right, first things first, let's add this 10 to both sides. Boom, 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 boom. Now we got 2 times x plus 3 squared is equal to 32. We're going to divide both sides by 2. We're going to get x plus 3 squared is equal to 16. All right, let's go ahead and square root both sides. That's what we are here for, the name of the game. All right, so that leaves me with x plus 3. Now, square root of 16, what is that? That is plus or minus 4. Okay, and the reason why we got to do number 1 is because we can actually simplify this. We don't have some radical that we can't combine. We're going to have some like terms going on here. So I'm going to split this one up. I'm going to draw this arrow in black so I could do red and green. So I want to write my first one. X plus 3 is equal to, I'm going to choose positive 4. And then I'm going to do x plus 3 is equal to, I'm going to choose the bottom one, negative 4. Okay, do you guys already see why we might need to do this? We need to subtract 3 from both sides. So 4 minus 3 is going to give me positive 1. And then here I'm going to subtract 3 from both sides. Negative 4 minus 3, that's going to give me negative 7. Boom. So this one is actually two different answers. I can't say x is equal to plus or minus 1, 7, right? That just doesn't work that way. So this is like that number 1 that I showed you. So maybe put something like that. You do want to do this at some point, okay? All right, oh, fraction. Why do you do this to me? Because they easy. It's not a big deal. Let's just go ahead and work through it. All right, boom. I'm going to add this 12 to both sides because that's what I do. 12 is an awesome number. My main man, Aaron Rodgers, boy. All right, so we got 1/2 times x minus 13 squared is equal to 12. How do I get rid of this 1/2? Well, we've done that a million times. We multiply both sides by the denominator. This goes away and we're left with x minus 13 squared is equal to 24. Let's go ahead and square root both sides. We get x minus 13 is equal to plus or minus. I can reduce this, or simplify it, I should say. That's actually going to be 2 radical 6. Okay, I just skipped a step. You guys should know how to do this. You mastered it in the previous section, so I'm cutting corners right here. Then I'm going to add that 13 to both sides. I get 13 plus or minus 2 radical 6. Boom, that's it. All right, pause the video. Try the last one on your own. Let's see if you can get it, and come on back. All right, welcome back. So this is what I got. I got x is equal to negative 4 and negative 6. So this one I did need to split up into number 1 and number 2. Two different equations because you had that plus or minus 1. All right, so that is it. That is all I got for you guys. Hopefully you enjoyed this video because it is massively shorter than the other ones, but since we've already mastered simplifying radicals and solving an equation, it was just a matter of time that we mix them two together, come up with something beautiful. All right, so please, 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 we're going to practice. It takes a little bit just to, make sure you just don't make mistakes. And we all good. And I will catch you on the next one. I had a blast. All right, peace.